Good afternoon to everybody. I'm going to present a webinar on the title An Innovative Multidisciplinary Active Learning Task Towards OBE, a case study done at RV College of Engineering at Bangalore. I am Professor Uma Rao, a professor in the Department of Electrical and Electronics Engineering, and this paper was presented in the conference at Pune, and my co-author was Professor V. Prema. So I'm going to discuss some interesting activity which was introduced in our curriculum and which I think has met many program outcomes. Now, self-learning is what motivates you to learn throughout life. And if you look at our program outcomes, or the graduate attributes as they were called earlier, the 12th one says to sustain longing for self-learning. So with this objective, different autonomous colleges have introduced the self-learning concept in different ways. Some of them are as follows. So a couple of colleges, what they do, in their curriculum, they introduce some topics which are basically not dealt by the staff member, and the students are expected to learn by themselves. Eventually, these topics go into the semester end examination along with the other topics handled by the teacher. So there is not much of a difference here except for the fact that the student learns the topic by themselves. In the second model, some colleges, they have a self-learning exercise which is more like a tutorial, maybe slightly tougher than a tutorial. And while we were debating on how to introduce self-study, we came up with a unique model, which is what I will be discussing now. So in this model, the student takes a very active role in learning a topic. The task is as follows. Let me describe the task. First, normally we have a class of 60 students. So the whole class is given 2 topics. So in the case study I am presenting, the topics considered were 3D printing and hybrid power systems. So 2 topics are given. So you have roughly 30 students allotted a particular topic. This is the first step. So 2 groups of 30 are given one of the topics. Next, the 30 students, each one of them has to select a subtopic within the main topic. So for example, supposing I consider 3D printing, some of the subtopics could be a vending machine with a built-in Delta 3D printer. So this is a topic by itself. Or a 3D printing by electron beam freeform fabrication. So this talks about fabrication process in 3D printing. Or a 3D printed bicycle, which is an application of 3D printing. Maximization of colors in 3D printing. First combat aircraft with 3D printed parts. This is another application. 3D printing in textiles, a novel application. So, what you come to know about this is, from the main topic, the students evolve and choose many subtopics. So, if you club all the subtopics together, it would give a very, very comprehensive picture of the main topic. So if you take the topic under consideration, we look at the hardware part of it, the 3D printers, how they work. Then students have chosen what softwares are available for 3D printing, and then they have chosen the different materials which can be used for 3D printing, and then different applications. So multifaceted dimensions of the topic are dealt by the students. Then the next step is every student collects information on the particular subtopic. So this information could be using the net or any other resource. So this is about the task. Then what the student has to do is where the novelty is brought into the activity. A question which bothers most of the students is that they feel quite a lot of the subjects they study to be irrelevant. They do not understand what is the relevance of different courses to engineering and technology. So, and I could say the lacuna also lies in the fact that many of the engineering subjects are treated like mathematical courses. Typically, if you take signals and systems or control systems, there is a lot of maths involved, but somewhere down the line, the faculty forget that it is an engineering course and not a mathematics course. So the whole course is dealt with numbers and problems, and the students end up doing the problems well without knowing what is the application. So one idea of this task was to bring out the relevance of courses studied by students. So this particular topic was given to the second semester students or the first year students, and they have many subjects, primarily basic electronics, mathematics, computer programming and mechanical engineering. Now what the student has to do is relate these topics, the topic which the student has chosen, to these subjects. What I mean is this. I will explain it with the help of an example. Consider the example of 3D printing of metals. So now the student has to gather information on this topic and also bring out with his or her own thought process what is the role of basic electronics, mathematics, computer programming and mechanical engineering related to this particular topic. So let me continue with the example. So one student said, what is the use of computer programming? So the student had found out that there is a software called Slicer to create G codes to give instructions tailored to a particular printer. So the student learns a little bit about the software, and the student understands what is the role of studying computer programming. Here the focus is not on whether C is important or C++ is important or Java is important. The focus is on the fact that programming has an application in engineering and it is not just a set of random code. Then, electronic circuitry and microcontrollers are used for control of the 3D printers. So the student understands the relevance of learning basic electronics course. Then, elementary mechanical design of the printer. What should the printer look like? What should be their clearances? How is the structure so that the material can be printed and so on. A brief idea about the mechanical design. And then mathematics is something very, very difficult to relate as an application. So now the student analyzes the fact that in 3D printing, an n-dimensional object is represented as a spectrum of n-1 dimensions and the various mathematical computations, and this illustrates the relevance of the study of mathematics to engineering. Now, I want to stress that the student need not go in depth. For example, the student need not go into the actual mechanical design of the printer, or the student is not expected to create a code, a G code using a slicer and so on. That is not the objective. The objective is simply to help the student appreciate the reason for introducing different courses in the undergraduate program, which later they will have an application when they go into the workplace. So that is the objective. Now, after this, what does the student do? So the student basically, if you have followed, collects the material, then tries to see what is the relevance of each subject, and then we ask the student to analyze what could be a problem in an implementation and what are the challenges. This is just to inculcate a thinking process in the student. So this is what the student has to do. So the student does this over the whole semester, and the student evaluation for this is done by presentation in two phases. In the first phase, the student gives a broad overview of the topic and what the student has in mind about how to progress. In the second phase, the student makes a presentation about the relevance of each subject, how they are related to the particular topic under hand, what are the challenges and what are the problems. So this is what the task is all about. Now, this example I have given you is from a first year level. Now, as the students go higher up in the semesters, they are expected to make a model, maybe a simulation model, or a lab prototype, or maybe a detailed economic analysis or a detailed design. So the option is given to the student. In fact, we have modified this by letting the students exercise their option in choosing what they want to do, like do they want to build a model, or do they want to go out to the field and do a case study, or do they want to build a actual lab prototype, or do they want to take a survey. So each one of these activities has different use for the students. And at higher semester, the depth of work expected is definitely more than what we expect from a first year student. For example, the same batch of students in the next semester, we gave them a topic of home automation. So they came up with different types of home automation possible through the mobile, through RF, through IR sensors, so many things. And each one of them, and sometimes individually or sometimes in teams of two, they built excellent prototypes. Maybe for remote control, or maybe for control through mobile, control through internet, control through the cloud. So they came up with fantastic applications for all of them. And they were absolutely self-taught. At the end, the student also submits a written report on the topic. Now, let us just look at what are all the objectives the task meets. I hope all of you are aware that what we were calling as the graduate attributes earlier are today called as the program outcomes. So now let's see what outcomes are met with this task. First, the objective of the task was to meet different program outcomes. The program outcomes addressed are as follows. The student obviously has to apply engineering knowledge because they are going to know where their knowledge acquired is going to fit in. So this is program outcome 1. Next, they learn the skill to integrate multidisciplinary subjects to solve a problem. So this directly maps to the second outcome of problem solving. And in the process, as I said, they at least come to know they are exposed to what kind of software is available for simulation and presentation. So let me share with you that some of the students have made excellent presentations with animation, with videos, and with hidden files which can be opened if you request, and so on and so forth. And this has given them a lot of impetus to understand that simulation is also a big part of engineering. So they learn and they are exposed to modern tool usage, which is our fifth program outcome. Now, what we insist in this particular activity is that the student has to analyze the problems of safety and the effect on environment and sustainability if they are going to come up with a product. Now, what happens in engineering courses, these outcomes are not addressed much. Therefore, we thought this is an excellent opportunity because the student learns so many things. For example, when they were doing 3D printing, they were asked to analyze whether there is going to be any environmental hazard because of the different kinds of materials used in 3D printing. Next, if I have a 3D printer, there was a case study where guns were printed, manufactured with 3D printing. And this led to a heated discussion on, is it safe? Is it safe to let anybody have an access to a 3D printer, in which case anything can be printed? So where do I go for licensing if I can print a gun with my 3D printer? So these kind of question and answers, I mean, the students are taught to go through this, and so they come to know that there are safety issues, and a product which may appear very good technologically may not be safe, may not be environmental friendly. The other thing I insist for the students when they propose something is to look at scalability. So very often students do not have the concept of scalability of an idea. So they come up with a lab prototype and whether they can scale it up. For example, if they do a home automation project, can it be scaled up to a real-time home? Can it be scaled up to a house which extends, say, over half an acre of land, and so on? So these are some of the thought processes we encourage them in this particular task. And definitely their communications are improved because they go through the presentations right from the first year level. And we feel that this would sort of inculcate a lifelong learning in them. Otherwise, this outcome of lifelong learning is very elusive and I would say intangible. How do I know when my student passes out that I have sent him out of the course with a longing for more learning? It's very difficult to measure or even assess, but we hope that this sort of self-learning would promote the longing for learning in them. Now, where does the teacher pitch in? Not much, I would say, but there is some role for the teacher. First, sometimes, especially in the lower semesters, the students find it difficult to find a subtopic. After all, under a main topic, we have to find 30 subtopics. So sometimes we help the students to choose a topic. And if they fail to get a material, we help them how to get the material. And some students, especially in the lower semesters, find it difficult to interpret whatever they have collected, the material. So the teacher helps them through discussions. Approximately, we interact with the students 1 hour a week, especially for this, to clear their doubts or to involve in any active discussion. But apart from this, the students are free to contact the teacher anytime. So 4 teachers are involved in this task. I told you that the student needs to find the relevance of 4 courses for the topic, and all the 4 teachers who teach those particular subjects will be involved in this task. And during presentations, definitely the teacher with their experience can give some value-added information to enhance the learning of the student, and not only the student but of the whole class, because everybody is sitting and listening to the presentations. And we encourage the students to actively participate and improve by giving critical review during presentations. So you see the teacher's role is minimized. We are only facilitators towards the learning process. And how do we evaluate? So we have created a sort of a rubric. I will not go into the details of the rubric, but we assess the student based on the topic of selection, the way the material is collected, the way the student is able to perceive the relevance of different courses for the subject, the communication skill of the student, and then the presentation of the slides. We mean the visual presentation. Are there animations to enhance? Is there good graphics? Are there images? And so on. And finally, definitely to the question answer capability of the student. Is the student capable of answering the questions posed by the teachers or by the audience? So all these aspects are evaluated. So they are evaluated by all the 4 teachers based on choice of subtopic and its analysis, communication skill, quality of presentations, treatment of fundamental concepts and application of the different subjects, regularity in attending all sessions, timely submission of report. So the report writing is also stressed upon, and what I did last time was I told the class to prepare the report in different formats. For example, a couple of them did it in the IEEE double column format, and I told them to download Elsevier paper submission formats. Some of them did in Springer. So this was just to give exposure to the students about different formats available for report writing. We also give weightage to the quality of the report. Now, when we introduced this task first, all of us were skeptical about whether it would meet its targets. And like any new thing introduced into a system, there were a lot of debates and discussions. Many of the teachers felt that the students will not put in efforts, which we normally assume. Secondly, there is one credit in each of the courses for this particular task. So the other feeling was that it was too much, because put together for 4 courses, it's a 4-credit course, which is equivalent to 1 theory course or a lab we offer in the semester. So the general feeling was that the students would definitely not spend as much time as they would do on a theoretical course or a practical course. So there were a lot of skepticism and doubts in everybody's minds. And I think the best way to clear them is to take a feedback. So I have taken a feedback from different sections, and some of the questions I had given in the feedback were this. Were you given a briefing about the concept of self-study by the teacher? So many of the faculty often, we fail to explain to the student what is expected of them. So I think as teachers, we all would know it. Next, we wanted to inculcate self-learning. Did it actually achieve that? And are the students able to find material for a particular topic? Did it help them to break up the problems into simpler terms? After all, I've taken a big topic and I break it up into smaller ones. Did they learn something new about how to use tools for presentation? Did they think that it enhanced their communication skills? And did it improve their confidence? Because the teacher has no role here. So did it actually improve their confidence that yes, I'm good, I can learn something by myself? Then, were they able to see the relevance of the subjects they study? And were they given sufficient feedback from the teachers? Did the feedback lead to their improvement? And finally, I took an assessment from the students, feedback from them, whether they want to continue with the activity or not. So we are an autonomous college, and as long as we are within the framework of university expectations, we can make changes in our curriculum. So if the students had felt, that majority of the students felt they don't want the activity to continue, then we should have had a rethink. Now let's look at what the feedback did. So I had given a maximum score of 4 if they thought it was excellent, and 1 if it was poor. And so I have given the answers, and I have made an analysis. So for the first one, whether they were aware of it, the average score was 2.6. So this was an indication that the faculty had to spend more time with the students in explaining to them the task. The second question was whether it drove them to self-learning. And yes, 85% of them felt that yes, it did drive us to self-learning. Third was about the material. So we got a low score of 2.5, which means that many of the students could not get sufficient material. But I think this low score was primarily because I'm giving you the feedback from first year students. So they are still not very familiar about how to use the digital library and how to download IEEE papers and other indexed journal papers and so on. So at the first year level, they find it a bit difficult to find material. We did not have this problem at higher semesters. And I think this also is a task where they learn these things. Then, the fourth question was about breaking up a larger problem into smaller problems. So we got a score of 2.5 on 4. And again, this was because it was a first year. So the higher semesters really learned it. And in this process, if any of the student teams wanted to build a prototype or a hardware model, I introduced them to the concept of project management. So how they can divide it into small tasks, prepare a sort of chart, and how they can plan. This was also what was done. Then, the fifth question was about presentation skills, and an overwhelming 90% of the students felt that their presentation skills were vastly enhanced. Then, communication skills. Again, 92.5% said that their communication skills definitely improved. Especially the first year, the score is very high because they're very shy, come from different regions of the country, come from different backgrounds, and they generally find it overwhelming, especially the students who are not from big cities. They get overwhelmed when they come to a city like Bangalore, and this task sort of was like an icebreaker in the first year and vastly improved their communication skills. And did it boost their confidence? Yes, 85% of them said that it boosted their confidence. Obviously, they go on the stage, talk in front of people, talk in front of teachers, and know that they're being appreciated, know that they're being heard, and therefore their confidence is boosted. And in mapping the courses, the relevance of courses, yes, at first year level they did find difficulty, but they appreciated the fact that they needed different courses. So they told me that they no longer thought studying mechanical engineering was useless for an electrical engineering student. And similarly, the mechanical engineering students said that they no longer felt studying basic electronics was useless because they realized how much of electronics is there in mechanical systems. So that sort of the disgust, or I would say the indifference towards courses of other disciplines went off. And then 80% of the students said that they benefited from the feedbacks we gave them during the presentations. And what was very encouraging for us was 92.5% of the students said that they want to continue with the task. So that was very, very encouraging. Initially they were grumbling. They said, no, we do not want to do it. It's too much of time. We don't know how to collect material, and because they're not used to doing something of this scale on their own. But as the semester progresses, they started enjoying it. And the higher semesters, they say, yes, definitely we want it. We want it to go on, because they tell that we learn a whole lot of things. And the second advantage with this, if you have noticed, is I have chosen a topic of, say, 3D printing. So if any student has to go through 3D printing as a whole, it's going to be virtually impossible, because there are so many aspects. Now, by breaking it down into subtopics, the whole class learns every aspect of 3D printing. So there is a comprehensive knowledge about the course as a whole. So that was very, very important aspect of this whole exercise. Now, as a facilitator of this activity, what I have observed, these are my personal observations: improvement in communication and presentation skills, improvement in ability to give different perspectives to a topic, ability to know challenges faced in an implementation, because during the question and answer session, it slowly evolves. Because you see, they are being questioned not by one teacher or two teachers, they are being questioned by 60 students, their own peers. And we all know they like to pull each other's legs. So in that process, the gaps in a particular topic come out into the surface. So what are the challenges? Do you think this is actually feasible? Do you want to do it? What are the ethical issues? What are the sustainability issues? What is the cost involved? And so on. And I definitely found confidence blooming in the students. And the competition between the students helped improve performance of all the students. One remarkable feature I found was, in the first phase, students who come from a rural background or a semi-urban background, or some of them who have studied in local languages up to 10th standard and then go to an English medium. So these are the students who feel, it's a personal perception of themselves, who feel that they lack something which maybe the convent going English medium students have. So we have a vast group of students, say about 50 to 60% of the students, who just do not get into the mainstream. Or I should say they are the mainstream, because they are very hesitant. So they are very quiet, do not ask questions in the class, very inhibitive and not able to mix with the local crowd and so on. But this task really helped them, especially at the first year level, to get to level, I would say, to create a level playing ground for all of them. And this was for me a bonus, apart from all the other objectives I mentioned, because I as a teacher feel it's also very important for me to see the class as a whole grow and mature, and not just a group of students who have an edge, maybe because of their background or because of their education. And now my students no longer complain about any subject being irrelevant. You see, as they go to a higher semester, for example, take 4th semester, they relate subjects like field theory, power electronics, machines, and control systems. These are the 4 subjects. So they are given a topic. So then how do they relate all of this? It's very exciting. Actually, it's very exciting. For example, some things are not very obvious. For example, electromagnetic fields. That's a subject which students hate because it's very tough and they never get to grasp the importance of that. So how do they even bring field theory? You know what I realized as a teacher of field theory was that they never even knew where the fields are. They don't even know what is happening. They think that electromagnetic fields is there only in a 400 kV line or a 230 kV line. They do not realize about fields in electronic circuits, about interference, electromagnetic interference, what is the limiting speed when you design a chip because of the electromagnetic fields, and so on and so forth. So I think this aspect was something very, very beautiful about the whole task. So as they grow on to higher semesters, they learn to relate seemingly unconnected topics. What is digital signal processing, for example, to do with induction motors? And then, yes, we give them a topic on condition monitoring. So then they realize, yeah, to do a condition monitoring, I have to do a signal processing. And then to do a signal processing, I have to know DSP. So that way, the link in the courses is formed. And today, I'm very proud to say that after 3 years, this is no longer a problem for us. So to conclude, I will say that the self-study, what we call it as self-study, addressed multiple program outcomes. The active learning improved the students' quest for self-learning. Their communication skills were drastically improved, and students, all majority of them, want the activity to continue. And we have decided, we have again framing our syllabus for 2016, we have decided that we will continue with this particular activity as it has given a lot of benefits. Thank you. Now I open the session for any questions from the audience.
How to differentiate between a pure theory course and practical course with theory?
Sir, I didn't get your point. How to differentiate?
Between a pure theory course and practical course with theory.
So a pure theory course is for example, if you take electromagnetic field theory, they don't do any practicals in that. Because, you know, we teach the magnetic field or the electromagnetic field concepts as they do a machines lab, or when they do their electronics lab, we have to tell them. So we do not have that. So what we are doing is, you are asking about this particular, if you are asking about this particular activity, yes, we do have this even in subjects which have a lab component. So in the lab, they do experiments pertaining to a particular course. So in this activity, they do a multidisciplinary introspection of the topic on hand. Any other questions?
Most universities have set curriculum and exams based on this curriculum. How do you introduce application-oriented courses such as you described?
Yes, sir, I agree with you. If you are an affiliated college to a university, you may not have flexibility. But I think the activity can still be introduced. So maybe you can have an incentive like a competition or something for the students. See, if you're an autonomous college, then definitely you will have flexibility, because even UGC gives flexibility to autonomous colleges. So if you don't have autonomy, it would be difficult. You have to find ways of introducing it. You can't possibly introduce it into curriculum. Maybe you can introduce it like a competition. Or maybe you can make it as an exercise in your labs. for the lab course, you can make it as a small exercise, 2 experiments. Maybe you can do it additionally. Are there any other methods followed for self-study?
We'll just give them 1 or 2 minutes. We are waiting for questions.
Yes, yes.
How do we implement the practical aspect of the subject for old syllabus running by the universities?
So can you repeat the question? How do we implement?
The practical aspect of the subject for old syllabus running by the university.
I didn't get the last part. How do we implement the practical aspect of a subject?
For old syllabus running by the universities.
You cannot do it, sir. See, if you are affiliated to a university, unfortunately, the university prescribes the syllabus and gives it to you. So you are very, very limited. But what I would say is, again, this is similar to the question asked previously. What I would say is, all of us can set aside 2 hours in a week and make the students do something different. Okay, let me tell you what you can do in a practical course. See, the university may prescribe 10 experiments for you. So let us say the lab course has 100 marks, internal marks you give. Now, you can encourage the students to create experiments which is not available, which they are not doing in the lab. So the students who get to do some new experiments can be given some extra marks in their lab course. For example, I have done this. I am taking the control systems lab. So I told the students, you do anything. You do, maybe you create a virtual lab experiment, or you come up with an experiment which is not there in the syllabus. It could be a hardware, it could be a simulation. I gave them the flexibility. And yes, they did come up for the control systems. A student came up with a very beautiful model to demonstrate chaotic systems. So chaotic system is something which they don't do in their lab. So I think this way, even colleges affiliated to universities can bring in some sort of self-study into their curriculum. Otherwise, your students will be missing out on a lot, and not all college can become autonomous.
Those are all the questions, ma'am. Thank you very much for the webinar.
Thank you, Mr. Shrida. Thanks to all of you for being on the webinar. Thank you.